Good day and welcome to our class. We want to consider more examples on equation of circle. Now let's take this example. We want to obtain the equations of sphere through this common circle. We know that this sphere and this plane becomes a circle, which intercepts this plane in a circle of radius 3. The first thing is, let us first find this circle. We know that any circle that passes through this will become s plus mp is equal to 0. So that is this plus m times this equal to 0. And that will give us this. So as you can see, this is our s, m is our p, this plane. So we now need to simplify. And when we simplify, we are going to get this expression. So this is the required equation of circle. But unfortunately, we have not known the value of m. If you have known the value of m, then we are going to get our answer directly. Now, the question says that this circle, this sphere 1 intercepts this plane in a circle of radius 3. And we are not told, we should know that when a plane intersects a circle, it intersects a sphere, it becomes a plane. So this is what we are trying to say. So this is the circle 1. It intersects a plane here. So this is plane s plus y equal to 0. Let's say this is the center of the sphere, and this is the radius of the sphere. Let's say this is m. This is radius of the circle here. This is o, which is center of the sphere. But now we have been given the radius of this circle here to be 3. So let's put that there. So we need to find the radius of this sphere, and we know that this one 0 to this place, o to this place, sorry, is the distance from the center of the sphere to the plane. Now let us first find the radius, that is the radius of 1. So the radius of this sphere 1 will now be equal to r. We need to first find the center. So let's find the center before we come to the radius. Center of the sphere 1. So is this. We know the center to be equal to negative of half of this. That is minus m plus 2 divided by 2, comma, negative of half of this 2 minus m plus 2 divided by 2, negative half of this, that is minus m over 2. So that will be the center. We now find the radius. So radius r, it will be square root of square of this plus square of this plus square of this minus this constant here, and that will give us, and that is what we have here. Now if you simplify further, if you simplify this thing further, we are going to have this for our radius. Now we have found the radius of the sphere. The next thing now is we need to find this length, distance OM, and we know that OM is same thing as L. OM, that is length of this line from this center of this sphere to this plane. And how do you get that? We need to substitute. So this plane is s plus y equal to 0. Then we substitute. This is our x. If we substitute it, we have minus m plus 2 over 2 minus m plus 2 over 2. There is no z there. We close it. Then over square root of their coefficient square. The coefficient of s there is 1. The coefficient of y there is 1 as well. So we have minus 1 square minus 1 square. And this will just give me m plus 2 after we have taken the absolute value over square root of 2. So this will be the, let me say this is 3. So this will be our length OM. Now by Pythagoras theorem. So we have this by Pythagoras theorem. So that is from this. We now need to substitute those things. OM. So we have seen our OM, but there is square there. So this will just be m plus 2 squared over 2. Because if you square this, it will become 2 plus MP. MP is the radius of the circle. Is given. This is 3 squared equal to OP squared. So what's our OP? OP is the radius of the sphere, and this is radius of the sphere here. So by the time we square it, the square root will just go. Don't forget that this thing is carrying everything there. So it will be 3m squared minus am minus 8 plus 8 over 4. So this is, we now need to simplify this, and when we simplify it, we are going to have, so we have this. So finally, when we solve the quadratic equation, we should be able to have m is equal to minus 2 or m is equal to 18. Then what we now need for us now is we substitute m is minus 2 or m is minus 18 or m is 18 into this equation. We put m is minus 2 there, or 18. So we are going to get these two. So when m is 2, we get this. When m is minus 18, we get this. So those are the required equations of the spheres. Now let's take another topic. So the other topic is still on spheres. Now we move to angle of intersection of two spheres. So we have it here. Angle of intersection of two spheres. So we have these two spheres here intersecting at this place. Now the angle between them, it will be the angle of the tangent plane, angle of the tangent to the sphere at the point where they intersect. So and it will, if you look at this diagram now, you see that it's still the same thing as the angle between their radii. The radius of the first, we assume that this is let me say radius 2. This is radius 1. Don't mind my drawing, it's not drawn to scale. So I'm assuming that this is the center. I'm assuming that this is also the center. So the angle between these two spheres will be the angle between their radii or between their tangent planes. Now let's consider condition for orthogonality of this, that is the angle between them. If it is orthogonal, that is if the angle between them is 90 degrees. Now let's assume that theta is equal to 90 degrees. So that is, they cut each other orthogonally. So let's assume that the angle here, this theta, is 90 degrees. We want to look at the relationship between these two spheres. So now let us represent a certain equation for this sphere and a certain equation for this sphere. So now let all these two be intersecting sphere. So let's assume that this is the first sphere here, and let's assume that this is the second sphere. So since theta is 90 degrees, since theta is 90, let me put point C in this place where they intersect here. Let's put point C there. So since theta is equal to 90 degrees, then ABC, we know that it's a right angled triangle. So we know that ABC is right angled triangle, and by Pythagoras theorem, so we should have that AB squared must be equal to R1 squared plus R2 squared. Abi, I see. That is, if this is 90 degrees, definitely this will be the hypotenuse. One of these will be adjacent and opposite. Now we have known how to find the radius of sphere. AB, what is our AB? A is the center of the first sphere. B is the center of the second sphere. So we need to find it as follows. Now A will be the center of this first sphere, and the center of this one is minus this, minus this, minus this. And we know that B is minus F2 minus G2. Let's say this is 1 minus H2. So that will be the center, and we have known their radii. So also, we know that for the first radius, this will become F squared plus G squared, F1 squared plus G1 squared plus H1 squared minus to be minus K1. Similarly, we can find our second radius too. As this is our second radius. Then we can find our AB too. So we know that AB squared is distance between these 2 points. So it will just be F1 minus F2 squared plus G1 minus G2 squared, finally plus H1 minus H2 squared. So that will be the distance between these 2 points. So we can now make use of this Pythagoras theorem. By that, AB squared, this is our AB square here. We write it out. This is our R1 square. This is our R1. We remove the square to become square root. We remove the square root to become square here. Likewise this. So by doing so, we are going to have this. Now, by simplifying, when you expand and simplify, some of all this F1 square, F2 square will leave. So at the end of the day, you are going to arrive at this. F2 F1 F2 plus 2G1 G2 plus 2H1 H2 minus K1 minus K2 equal to 0. So this result is the condition for two spheres to cut each other orthogonally. When we say that two spheres cut each other orthogonally, then this must happen. So let's take note of that, and let's take the following example. So we have this example. Find the angle between the spheres, this and this. So before we find it, we first need to find the tangent plane at the two spheres. So the tangent planes to these two spheres at this point will become following. So we start from the first one, which is S into S1. This is 2 plus Y into minus 1 plus Z into 1. We have done this before. Minus this minus 2 over 2 into S plus this one plus, we divide it by 2, Y minus this minus 3 over 2 into Z minus 1 plus 2 equal to 0. That is minus 3 over 2 into Z plus 1 plus 2 equal to 0. So we now need to simplify this further. So by the time we simplify it, you are going to get this. Also, we find the tangent plane at the second one. So this will be S into the same thing plus Y into minus 1 plus Z into 1. Now we are under this now. This is minus half into S plus 2. This is minus 2 over 2 into Y, but the plane is the point is minus 1 there, and Z is 5 there. 5 over 2 into Z plus 1. There's minus 11 here. Minus 11 equal to 0. So we simplify this further. When we simplify, we are going to get this. So before we find the angle between this, we need to find the normal vector to these two. So the normal vector to the planes 1 and 2, this plane. So the normal vector becomes, this is 2 comma minus 1 comma minus 1, and the second plane is 3 comma minus 4 comma 7. So if you still remember, the formula is n1 dot n2 over absolute value of n1 and absolute value of n2. So theta is what we are looking for. So this is 2 comma minus 1, 2 comma minus 1 comma minus 1, dot the second one 3 comma minus 4 comma 7 is the first one over 2 squared plus 1 squared plus 1 squared times the second one is 3 squared plus 4 squared plus 7 squared. So cos theta is equal to, we multiply this, 2 times 3 is 6, minus 1 times this, that one is 5, minus 1 times this, that one is minus 7. So this one is easy to do with our calculator. So by the time we finish it, we should be able to have 2 roots 111, and this is very easy. So 6 plus 5 is 11. Sorry, this is 4 minus 1 times minus 5, 4. This is 4, not 5. So this should give me 6 plus 4 should give me 3 divided by 2 root 111. So from this place we can see that our theta is arc cos 3 over 2111. So by the time we finish this from our calculator, we should have 81.82 degrees. That will be the angle between the two spheres. Let's take another example. We have another example here. We have to find the equation of a sphere passing through this point, this circle. Firstly, we know that the required circle will be S plus MP equal to 0. So, which is this? And we simplify, we are going to get this. Now, let's say this is the required sphere. So F1 there, this is our F1. So we divide this thing by 2. So, and that will give me 3m minus 2 divided by 2. So G1, we divide this by 2, that is minus 4m plus 3 divided by 2. And H1, we divide this by 2, 5m minus 4 divided by 2. And K1, this is 6 minus 15m. So let's take note of that, or let's call all this 1. Now, the sphere 1 cuts this sphere, this second one, orthogonally. So we need to know the F, G, and H and K as well. So F1 here is, we divide this by 2, that is 1. F2 is, we divide this by 2, that is 2. And F3, we divide this by 2, that is minus 3. And our K2 is 11. So since the two spheres cut each other orthogonally, then this happens. We have proved that before, which is this. So we now need to substitute those things there, 2F1, F2. So when we do that, we are going to have this. So that is it. We have merged them together. This times 2. The 2 will cancel this. It will remain this left. These 2 multiply. Sorry, this is F2. Sorry, G2 and H2, just like this. So G2 and this, we multiply each other, just like what we have here. So by the time we simplify this equation, we are going to get m is equal to minus 1 over 5. So we cannot substitute minus 1 over 5 into this place. Wherever we see m, we substitute. And when we do so and we simplify, I'm talking about this one or this, any of the two. When we do so and simplify, we are going to get this as the required equation of sphere. Let's take another example. We have another one here. Find the equation of the sphere which touches this plane at this point and cuts orthogonally this sphere. So the first thing is, we are told that the sphere touches this plane. Definitely this plane must be tangent to it, since we have been told that it touches the plane. Now let us represent the sphere by, so let the sphere be this. Now the tangent plane to the sphere becomes s times our, this is our s1, this is our s2, this is our s3, s times s1 plus y times minus 2 plus z times 1 plus 2fs, that is plus 2f over 2 as usual, into s plus 1 plus 2g over 2 into y minus 2 plus 2h over 2 into z plus 1 plus k equal to 0, which when we simplify we are going to get this. So let's say that is 2. So this 2 now is tangent to 1. So since 2 is tangent to 1, we have been told that this one is also a tangent plane to the same one. Definitely they must be equal to each other. So that is what you have written. Since 2 is tangent to 1, it must be the same thing as the given tangent plane. So we compare. Then by comparing, by comparing 2 and 3, this place and this place. Normally I would have said that f plus 1 is equal to 3. But the question still further. The question says that it is orthogonal. The sphere we are talking about, this sphere, is orthogonal to this one. So this is what I will do. I will just say that if you compare, we are going to have f plus 1 is equal to, instead of 3, let's assume that we have 3m there. As usual, since it's orthogonal to it, then they cut each other at 90 degrees. So we can say that g minus 2 is equal to 2m. Also, h plus 1 is equal to minus m. And finally, this one, f minus 2g plus h plus k, this one will be equal to 2m. So from this list, I can find the value of m here, f here. So which will be f is equal to this from this place. Our g will be equal to this, and our h will be equal to this. So if you now substitute f, g, and h inside this one, this is our f minus 2, this is our g, this is our h plus k is equal to 2m. By the time we make k the square formula, we are going to have this. So let's call this 4. So we keep it like that. So we continue by also 1 cuts orthogonally. This sphere. So this is sphere we have written here. Let me call this 5. So we cut this orthogonally, that is this sphere 1. Cut this. Don't forget that the sphere 1 has this FG, FGH, and this is the K. So and if they cut each other orthogonally, this must happen. So we now have 2 times F1. Our F1 is 3m minus 1 times F2. So our F2 will be this divided by 2. That will be minus 2 plus 2 times G1. This is our G1. 2m plus 2 times, we divide this by 2. This will be our G2 times 3 plus 2 times H1. This is our H1 here. Minus m minus 1 times, there's no h here, that will be 0. So it will be minus k1. Everything here is our k1. That will be minus 4m minus 6. Then minus k2, this is our k2 here. Minus 4 equal to 0. This is a linear equation. We can solve this. And by the time solving this, we have m is equal to 5 over 2. So since we have seen that our m is equal to 5 over 2, then I can now find the value of my f. This is our f, this is our g, this is our h, this is our k. You really need to substitute m to be 5 over 2 there. When we substitute 5 over 2 and we simplify, we are going to get all this. So we have found the value of L, G, H, and K. We can now substitute it here. And when we substitute and simplify, the required sphere will become this. So that is the required equation of sphere. Let's take another example, but this one is relating to a line. It's not a sphere. This is very important. So we have to find the length of the perpendicular distance from this point to this line, and also find its equation, that is equation of that line. If you want to do this, we need to draw the diagram so that we understand. Sorry, don't mind my drawing there. So we are looking for length of this line from point 213 to this line here. This is a line. I don't want to write it again, but this line has direction vector 4, or direction ratio 4, 4, 1. Now, but we are told that it will be perpendicular to this line. The first thing we should take note is that the line we are looking for passes through point 2, 1, 3. Now, this line here, this line is given as this from the given line. You know, we can have that if we let everything to be equal to t. So, you know, we can have s is equal to 4t plus 3, y is equal to 4t minus 2, yz is equal to t plus 1. So we have that. We cannot have that. Let me put A here, or let me put B here, let me put C here, let me put A in this place. So now any point on this line BC here will be of this format, this comma this comma this. But don't forget that this place, this B, is also a point on this line. But B is also a point on that line B, as I have said before. So let our point B be this. So we know that AB is perpendicular to BC. We know that this AB from the equation is perpendicular to BC. So let's find the direction vector of AB. So what will the direction vector? Direction vector will just be this minus the x, this minus the y, and this minus the z, which is 3. So which is equal to this. So as you have seen, so that will be the direction vector. Since AB is perpendicular to BC, we know that the product of their direction vector, the dot product of their direction vectors will be equal to 0. So therefore, the 4, 4, 1, we multiply this. Therefore, 4 times 4t plus 1, 4t minus 3 plus 1 into t minus 2 must be equal to 0. Since their product, since the two are perpendicular, the product of their direction vectors or direction ratios will be 0. And by doing so, we get our t to be 10, t equal to 10 over 33. So since we have known t, therefore our b will be equal to, we substitute b for this. Anywhere we see t, we put it, and that will give me, so this will be our b. So since we have known our b, what did they ask us to find? We have to find distance between, that is length of AB. This is our A, length of AB. So where A is 213. So we use the formula of finding distance between 2 points to get this. Also, the next thing is we have to find the equation. So we use the formula for finding the equation of a straight line. having 2 points, that is s minus this s1 over y minus 1 over z minus 3 over, all will now be this minus this. We subtract all this in order to get so this one will be 139 over 33 minus 2. The second one will be minus 2 over 3 minus 1. And finally 43 over 33 minus 3. So I will leave that for you to finish it up. Have a good day.